Using Kirchhoff's rule, calculate the current through the 40 ohms and 20 ohms resistor in the following circuit. This is the following circuit here, that is in loop A, B, C, D, A and loop F, C, D, E, F. We are going to consider this as a two loops. Then we can find the values here. Like in the first loop, we get the value plus 80 minus 20 I2 plus 40 I1 is equal to 0. When I simplify, I am getting the value 4 is equal to I2 minus 2I1. This is, I am going to consider equation number 1. And in second loop, we get minus 40 I1 minus of 10 times of I1 plus I2 plus 40 is equal to 0. Then if I want to simplify, I am getting the value minus 50 I1 minus 10 I2 plus 40 is equal to 0. When further simplified, I am getting the value 5 I1 plus I2 is equal to 4. Then finding the value of I1 and I2 by equating the equation number 1 and 2, we get I1 is equal to 0 and I2 equals to 4. It is the unit is in terms of amperes. What is the end error in a meter bridge? How is it overcome? The resistance in the two arms of the meter bridge are R is equal to 5 ohms and S respectively. When the resistance S is shunted with an equal resistance, the new balance length found to be 1.5 I1 and I1 is the initial balance length. Calculate the value of S here. So this is the circuit they are given here. Here connected with the galvanometer. Okay. The total length is here it is from this point to here it is I1 and from here to here it is 100 minus I1. Then we need to find the value of the S in this particular case. The first we will discuss the what is the end error in a meter bridge. Okay. The end error in a meter bridge is the error arising due to the ends of the wire not coinciding with 0 centimeter or 100 centimeter marks on the meter scale. If it is not a mark on the meter scale, then automatically the end will be arise on the meter bridge. One more point, presence of contact resistance at the joint of the meter bridge wire with the metallic strips. With this also we can say some end error will be arising in the meter bridge. It can be reduced or overcome by finding balance length with two interchanged positions of R and S and taking the average value of S from the two readings. Then we can write this one as for a meter bridge we can write R by S is equal to 1 divided by 100 minus I. For the two given conditions, then we can write it as 5 divided by S is equal to I1 divided by 100 minus I1. Then 5 divided by S by 2 is equal to 1.5 I1 divided by 100 minus 1.5 I1. Dividing the 2, we will get the value 2 is equal to 1.5 I1 divided by 100 minus 1.5 I1 into 100 minus I1 divided by I1. Then we can simplify this one as 200 minus 3I1 is equal to 150 minus 1.5 I1. Then further simplified, I1 is equal to 100 divided by 3 centimeter. Putting the value of I1 in any one of the two given conditions, then we will get S is equal to 10 ohms.